All strong React developers stand atop a stable base of JavaScript, but there are certain JavaScript functions and objects that are more important than the others, and a strong understanding of these set aside the experienced from the beginners. If you are prepping for an interview or just want to become a better React developer, this video is for you. Let's get right into it. We're going to start off with intervals and timeouts. Intervals are so versatile and can be useful in setting timers, animations, waiting for data updates, and more. As a React developer, you need to know how to start and clear intervals within a component. To start an interval, we can use the setInterval function. It is most commonly used with two arguments, the function and the delay. The function is the code we want to run, and the delay is how often we want to run it in milliseconds. For example, function A will run every 100 milliseconds, or in other words, 10 times a second. The return value is important here. It is the interval ID. The ID is needed to clear the interval, which is done by passing the interval ID to the clearInterval function. Let's take a look at what this would look like within a React component. We typically use intervals within the useEffect hook. In the body of the hook, we set the interval. And to store the interval ID, we use the useRef hook. We store it this way instead of using a state variable, as updating ref variables do not cause a re-render of our component. And thus, we do not need to put it in the dependency list of the useEffect hook. And finally, in the return statement, we clear the interval. The return statement here runs when the hook cleans up. Since the dependency list is empty, the cleanup occurs when the component dismounts. Clearing the interval here ensures that the interval stops and does not cause memory leaks. Intervals are easy to get a hang of and are a useful tool for a React developer. Learning to use them also has a bonus. They are often needed to solve live coding interview questions. Now, just as important as intervals are timeouts. You would typically find timeouts being used to delay actions. Examples are to debounce search terms, or for toast notifications, or to redirect from pages after a certain amount of time. Just like intervals, we start a timeout and then we clear a timeout. To start one, we use the setTimeout function, which typically uses two arguments, the function and the delay. The function is the code we want to run, and the delay is after how much time we want to run it, in milliseconds. For example, function B will only run once and after 3000 milliseconds, or in other words, after 3 seconds. The setTimeout function returns the timeout ID. This ID is used to clear the timeout, which is done using the clearTimeout function. Now, let's take a look at a common use case for a timeout in a React component. Here, we are implementing a debounced search. This is typically used in autocomplete search, where we only want to make API calls when the user takes a break from typing. In this example, temp search term is what updates when the user types. But only updating search term triggers an API call. The useEffect hook is run every time temp search term is updated. When it does run, it sets a timeout to update search term with temp search term after 500 milliseconds. If the user types again before the 500 milliseconds are over, the return function is called that clears the original timeout and then resets up a new timeout. But if the user does not type again within 500 milliseconds, we update search term with the value of temp search term. That is all there is to timeouts, and just like intervals, you can get a hang of them very quickly. Okay, let's switch things up by looking at a very important object, the URL. This object helps us parse, construct, and encode URLs. These features come in handy whether you're interacting with APIs, extracting information from query params, or simply just linking to other pages. To create a new URL, we use its constructor. This is typically used with two arguments, the endpoint and the base. In this example, we can reuse the same base to form two separate URLs. The return value is the URL object. This has a list of functions and properties that can improve your developer experience. What I find most useful is the search params property. This can help while interacting with APIs, like when we want to add data in query params, or help with building a web page that needs to extract query params from the URL. The get, getAll, and set methods are the most commonly used ones. When building an API route, we can use a set function to easily add a query param. And while retrieving data from the URL query params, the get and getAll functions come handy. I am grateful to have the URL object in my JavaScript tool belt. And though knowing how to use it is not typically needed in a React coding interview, it will definitely improve your developer experience. Alright, let's move on to the third part of this video, events. They are typically triggered by user actions, such as clicking the mouse button, tapping the keyboard, or resizing the browser window, but can also be triggered programmatically, such as via the dispatch event function. In React, our components typically trigger events via inputs and buttons, listen for events via event listeners, and finally handle events using event handlers. A core feature of events is bubbling. To understand it, let's look at some examples. Let's say we have a button within a div. When we press on the button, a click event is fired on the button. But this event is also then fired on the div, as the button is within the div. Since it is fired on the button, then on the div, the event bubbles up from the innermost element that was clicked. This behavior is useful, but sometimes can cause problems. Say we have a card that displays text with the Read More button. Clicking on the card navigates us to a different URL, and clicking on the Read More button shows us additional text. Because of event bubbling, when we click on the Read More button, the click event bubbles up to the card, which then navigates us to a different URL. But we only want to see more text, not navigate away. In this case, we want to stop the event from bubbling, and that is where our first important function can help us, the stopPropogation function. When called on an event, it prevents the event from bubbling. In our case, if we add it to the onClick handler of the Read More button, we will no longer navigate away. Every large project that I have worked on has used this function. Another function that is often used with stopPropogation is preventDefault. This prevents the default action of an event. For an example, the default onClick event of a checkbox is checking or unchecking it. But if we add preventDefault to its onClick handler, pressing it will not check it. The event still continues to bubble up and is thus often used with stopPropogation. In React, preventDefault is used to take control of inputs and forms using state variables. Now that we know a little about events and working with them, let's look at how to handle them. The first way is event handlers. In React, a common event handler that you might have come across is the button's onClick handler. Here, the handleClick function passed in the handler is called when the button's click event is triggered. Other examples of event handlers are onMouseEnter, onKeyDown, etc. The argument the handler is called with is the event object. On this, you can use the preventDefault and the stopPropogation functions. In most cases, you would handle events using event handlers. But there is another way of working with events, and that is event listeners. Using them requires a little bit more effort, but they have their benefits. I primarily use them for window events, such as resizing the browser and scrolling. There are two functions needed to use event listeners. The first function is addEventListener. It takes two arguments, the event name and the handler. The event name tells our listener which event to listen for, and the handler is the function that runs when the event is triggered. The second function is removeEventListener. It needs the same arguments used in the addEventListener function. We must remove event listeners correctly to avoid memory leaks. In React, these two functions are typically used within the useEffect hook, where we add the event listener in the body of the hook and remove it in the return section. Now let's look at an example where a React component displays the width of the browser window. As I change the browser width, our component displays the new width. Let's look at the code. Width stores the current width of the window. It starts off as 0. Within the useEffect hook, we define a function called handleResize. This updates width with the width of the window. We call it once to set the initial value. We then add an event listener on window, listening for a resize. Now when the window resizes, the handleResize function is called. And finally, in the return section of the hook, we remove the listener. Event listeners are a super useful tool for a React developer, and I strongly recommend trying to use them in your next component. Before we move on to the final part of this video, if you're finding this video helpful, you can help me by liking and subscribing. Okay, the last feature you must know is the Abort Controller. It is an object that allows us to abort web requests. This is important in React as we often make API calls from within components and need to make sure that we abort the fetch request when the component unmounts. Not doing so can lead to memory leaks. I personally use this while working with APIs. Let's look at an example. Here, we are using the Abort Controller within a useEffect hook that is used to fetch data. The retrieved data is stored to a state variable. the constructor of the abort controller takes no arguments and returns the controller object. The object has only one property, the signal. This is what enables us to communicate with async operations. For our API call, we will be using the fetch API, and to it we will pass in the signal. The signal has a property called aborted. This tells us if the fetch call was aborted or not. If it was not, we update our state variable, but if it was, we do nothing. Finally, in the return section of the useEffect hook, we call controller.abort. This is the function that aborts the fetch request and sets the signal.aborted property to true. This ensures that if the component has unmounted, we don't attempt to set the state variable. The abort controller is such a valuable tool while trying to fetch data on the client side. I highly recommend trying this out in your next project. And that concludes this video. Everything you have learned today can help you with your React interviews, but more importantly, will make you a better React developer. If there are JavaScript features that really help you and I missed them in this video, please leave them in the comments below. I am the Helpful Coder, and thank you so much for watching.